Hi everyone and welcome back. In this lecture, we're going to take a quick look at the oldest medical imaging modality, projection radiography. Alright, let's have a look at an example to explain how projection radiography actually works. In this modality, images are generated using X-rays. These X-rays penetrate the human body and are partially absorbed by anatomical structures. The differently attenuated beams are then detected by a dedicated detector and subsequently converted to an image. Depending on the targeted body region, a different picture emerges, in this case the thorax. The image contrast in projection radiography comes from the different degrees of X-ray absorption between the X-ray source and the detector. This means that very dense or thick objects result in an X-ray shadow with less X-rays reaching the detector. On the chest X-ray, for example, bones are dense and thus have a different image intensity than the lungs, which are filled with air. It is important to mention that those intensities are relative values. Usually, you can assume that high X-ray absorption is depicted as high image pixel intensities, whereas low absorption is depicted as low intensity on X-ray images. However, please note that there are situations where the images are inverted. When a radiologist diagnoses an X-ray image, he or she often wants to measure some distances. Those distances are measured as the number of pixels on the detector. For us humans, however, it is close to impossible to interpret such a pixel distance. Therefore, a physical distance measurement, such as centimeters, would be desirable. We can obtain such a measurement by calibration. Calibration of the full setup allows us to approximately convert or translate pixel distances to physical ones. Alright, last but not least, let's look at some example images. Here you can see 3 different X-ray images. Within the left figure, you can see a thorax radiograph that revealed bronchial carcinoma within the left lung. The central image shows the examination of a hand without any abnormal findings. Last but not least, on the right, you can see the scan of an ankle during surgical procedure. In the next lecture, we will talk about three-dimensional radiography, also called CT. Thanks and see you soon.